avoid colliding with other cars while driving on a highway. We witnessed nervous basketball players bumping with each other during the last few seconds on a championship game. I am Princess Meneses to discuss the concepts behind these situations. For this discussion, we are to define momentum and impulse, state law of conservation of momentum, and differentiate types of collision. Momentum is the product of mass of the object and its velocity. Using P as a symbol for momentum, you have to remember that P is equal to mv, thus expressed in kilogram-meter per second. Every moving object has momentum. It may be large or small depending on the mass of the object. For example, upon taking a 0.02 kilogram drug, it traveled through the upper digestive tract with a velocity of 0.03 meter per second. Find its momentum. Through direct substitution, we have P is equal to 0.02 kilogram times 0.03 meter per second. So our momentum is equal to 6 times 10 to the negative 4 kilogram meter per second, or 0.0006 kilogram meter per second. The greater the momentum, the harder to stop it from moving. When a force acts on a body, there will be a change in its momentum. Thus, we can say that there is also a change in its velocity. This is what we call the impulse. It is the product of the force and time during which it acts. So, impulse is equal to force multiplied by time, and it is also equal to mass times change in velocity. Let's have an example. A mass 3 kilograms strikes another stationary object at 10 meters per second and comes to a stop in 2 seconds. What force acted on it? So we'll make use of this formula to derive the formula for force. So we will divide both sides by T, or time. Thus, force is equal to mass times change in velocity over time. Now, to substitute, 3 kilograms times 0 meter per second minus 10 meter per second over 2 seconds. So the force is equal to negative 15 kilogram meter per second square. Law of conservation of momentum states that the total momentum before an interaction is equal to the total momentum after interaction. To make it clear, let's have an example of an interaction, which is the collision. Collision is an interaction between two or more bodies that usually come in contact with each other. Collisions may be perfectly elastic and perfectly inelastic. In perfectly elastic collisions, linear momentum and kinetic energy are conserved after collision in which the bodies separate. In perfectly inelastic collisions, the bodies cling to each other and move with common velocity. Thus, linear momentum is conserved, but kinetic energy is not. Some of the kinetic energy goes into another form such as heat, sound, permanent deformation, etc. In all collisions, impulse, momentum, and conservation of momentum play major roles. To summarize our discussion, we defined momentum and impulse, stated the law of conservation of momentum, and differentiate the perfectly elastic and perfectly inelastic collision. Molecules of the substances that we are using for production of drugs consider collision. So, we have this ineffective collision, wherein molecules do not bind with each other, thus do not produce a new compound. In effective collision, molecules have the enough potential to bind with each other, thus producing new compound. Knowing these concepts, you've been aware of safety. And of course, you appreciate more the applications of physics to our program. This is Princess Meneses of BS Pharmacy from Our Lady of Fatima University. Thank you.